So now we know that we know that A is root x minus 1, and we know that R is 1 over root x minus 1. Then when we want to, and we also, hang on a second, we also know what x is, which is 2. So let's, instead of writing x, let's write 2. Yeah. And the equation is this. So the nth term, or in this case the fifth term, so t5. As I say, in the textbooks, it'll say x, but we use t because they had x in the question. It just caused some confusion. So it's going to be a. So, well, let's just write it out like this first. So it's going to be a multiplied by r to the power 5 minus 1. And a is this. And then it's going to multiply out by this, which means it's just dividing by this. Oh yeah, no, I got that wrong. No, I didn't. Well, yeah, sort of just haven't finished. And then I'm going to do that slightly different because it might be a bit confusing. So root 2 minus 1. And all that is to the power 5 minus 1, which is to the power 4. So basically what I did is I kind of skipped that step and I combined this and put that over at the bottom like that. So that would be to the power 4. And because we've got the top and at the bottom, they can cancel out at the top, and then at the bottom that will become 3. So let's just do that here with an eraser like that. And now we just have to just to confuse matters, we've just got to rationalize this denominator. So I think what's the best way to do this if it's cubed? All right, I'm overcomplicating this. Basically, we just imagine it's not cubed for the moment and rationalize it within the cube. So that could be rewritten as if it was all cubed, because, well, it's the same thing, like that. And then we just take this thing here and we rationalize the denominator. And the way that we do that is we multiply it. I'll show you. We multiply it. We're using the difference of two squares trick. We take this and we multiply it by root 2 plus 1 over root 2 plus 1. And we still have to remember to cube all of this at the end. So this will give us, at the top, we'll just have the root 2 plus 1. At the bottom, we're going to have, because this is different to two squares, we're going to have root 2 times root 2, which is just 2. And then we're going to have minus 1 times 1, which is 1. And so therefore, 2 minus 1 is just 1. Yeah. And that's still all cubed. So the bottom bit disappears because we're just getting 2 minus 1. And so now we just have root 2 plus 1, and we still need to cube it. Okay, so now let's do that. So the best way to do this is by just getting them 3 of them like that. And to do the first 2 and then multiply it out by the second one. Okay, we're running out of space again. I'm just going to do it off the page. And if you're in the exam, you just want to have to write a bit smaller than I'm writing at the moment. So Root 2 times root 2 is going to give, I'm just going to do the first two brackets first, okay? So then we're going to do plus root 2 because it's root 2 times 1 plus another root 2, which is because it's root 2 times 1, so plus 2 root 2, then plus 1 because we've got 1 times 1 there. And all this has been multiplied by the third set of brackets like that. Okay, and that's going to be 2 times root 2. That's the first term. So 2 root 2 multiplied by this one, multiplied by this one. So it's going to be root 2 root 2 multiplied root 2, which is going to be 2 times 2, which is going to be 4. Plus, and then 1 times root 2, which is just root 2. Okay, and then we need to multiply everything again by the 1, which, well, everything multiplied by 1 is just the same. So I can just copy all of that, apart from the bracket, and add that there. So that's all going to be added. There's no minus symbols to take into account. Now we're going to collect the terms. So we've got the root 2's, we've got 2 here, another 1 here, and another 2 there. So that's 5 root 2. And then the numbers, we've got 4, a 2, and a 7, and a 4, a 2, and a 1. That adds up to 7. And I believe that's what they said, hopefully, is what we had to prove it to be. Right. Oh, what's going on? It's jumping all over the place. Well, yeah, I got the 7 at the end, but yeah, there you go. Okay.